Okay, I hope everybody understands the basic syntax so far. So if you want to print something, then it needs to be done with the select clause. Okay, and every SQL instruction will end with a semicolon. So that is one of the most important things that you should remember. Okay, so let's say I just want to. One thing that you also need to know is that you can have these SQL instructions. Let's say if they are so big, so you may want to run in the multi-line mode. So if you don't, till the point if you don't enter a semicolon. So till then your instruction will not complete. So let's say if I type say something again, I mean this is not a valid instruction, but till the point I am entering anything, and if I don't enter with a semicolon, then this will continue. So this is nothing but a multi-line SQL instruction. So if I put a semicolon there, so the compiler will understand that the instruction has ended and it will try to execute this instruction. So because it's incorrect instruction, so that's why it is giving you an error. So this semicolon is really important. Okay, so let's say if you want to know what the databases are that exist in the system, so the command is show databases. So these are the databases that are available. So let me just show you the databases. So there are 5 databases. By default, you will have 4 databases. The classic models is one of the database that I have imported. So the other 4 you would see by default. Okay. So now let's say if you want to create a new database. So if you recall the SQL instructions from the last lecture, so the command to do that is create database and then any database name that you want. So let's say our database is DB. So you can see that the database is now created. I can just see if it is created or not by using the show databases command, and then you can see that this database is now created. Okay. So let's say if you want to use this database, so the command for that is use and the database name. So this is the database name. So I want to use this DB database. So use DB is the command to do that. Now with every database, you would see that there are several tables. This database is, this database DB, because we have created it just now. So there are no tables in it. So if I just see what the tables are, so the command to do that is show tables. So it is showing an empty set because we haven't created any tables so far. Okay. So if you want to create a new table, so the command to do that is create table, and then you can give a table name. So let's say the table name is say tname, and then you would start entering the columns that you would want in this table. So let's say the first column be the name, and it is of type varchar. So inside varchars you can specify the string length. So let me just increase the string length once. Okay, so then let's say if you want other columns, let's say the age, and if you prefer the age to be an int, so age would be an int. Okay, for now let's create a simple table, and I'll end the brackets and end with a semicolon. So you would see that this table is now created, and if I just run again the show tables command, so this table is now there in the database. Now if you want to see okay, let me just clear it again. So if you want to see the attributes and the characteristics of the attributes of a specific table, you just have to type describe and the table name. So the table name that we created was tname. So I can say so it will tell me that there are 2 attributes, the type of the attributes. See, null specifies that you can have null entries in this particular column. Key we will discuss in tomorrow's lecture, what can be the possibilities. There are actually different kinds of keys that you can have corresponding to a particular column. So we will discuss the concept related to keys in the next lab. Default tells you if by default, let's say if you don't enter anything, then what is the default value for it? So as of now, it is null. And there are some extra constraints that you could specify with a field. We will also discuss this in the subsequent labs. Okay, so now I have created this table. I have showed you like the possible, the different kinds of data types that could be associated with the different columns of the table. So now let's say if my goal is to add values to this particular table. So the keyword to do that is insert. So you would specify that in which table you would want to insert. So insert into tname, and what values you want to insert is. So you would specify that insert into tname values, and you could see that the first attribute is name. So let's say the first attribute is say Santa, and the second attribute is say field. So you can see that the values are inserted successfully. So now if I just want to see what rows exist in this particular table, so I can do that with the select clause. And star here tells me that I want to print everything. So select star from your table name. So table name is tname. So if I do that, so it prints that it has only one row, and the row contents are Santa and 23. So far, if you have any queries, let me know. Guys, I want you to interact. So,
sir, what is the last command? I didn't get it.
This one, insert into tname.
No. How do you see the table that select star from tname?
Okay. Yeah. So let's say if you want to print the entire table. So far, I have just created one table with the name tname. And there is one row inside this table, right?
Okay.
Which we made with this insert command, right? So I want to print everything from that table tname. So that's why it is the you can say the asterisk, the star represents everything. So let's say if I want to print only the names from my table, so I can say select name from tname, and it will only print the name column. If you want to print only age, so you would say that select age from your table. Is that okay?
Yes, sir. Okay.
Okay. So let me insert a few more values so that we can run a few more commands. I mean, I'm just taking vague values, so don't quote me on that. Okay, so now if I show you the contents of the table, so these are the 5 rows that I have, sorry, the 4 rows that I have in my table. So let's say if I want to print a specific row from this table, so that I can do. So let's say I want to print that specific row where the name is Santa, or let's say the name is Fanta. So select, and I want to print the age of that person. So select age from tname. Now, whenever you want to put any constraint for the rows you want to print, so that will come inside this where clause. So where tells you this. Sorry, this where tells you that you are about to enter a constraint. So the constraint here would be name equals, and let's say we want to print. So it has shown me, because we were just printing the age from this table where corresponding to the name Fanta. So this is how you can do that. Okay. Let's say you want to select say the maximum and the minimum for numeric based columns. So if you see this particular table, sorry. So there are two types of fields. One is name, one is age. Age is a numeric type. It's an integer type. So I can do these so let's say if I want to have the min, max, average, all such operations done on a numeric field. So I can do that using. So let's say select min, age. Let's say you want to print the name as well from. Oh, sorry. Oh, I missed out. Oh, wait. Oh, yeah, I think it has to be only this. I'll tell you what an aggregated query means. So if you want to just print the age, the minimum age, so you will do that in this way. Let's say if you want to do the maximum age, I will tell you how to print the corresponding name as well. Just give me 1 second now. So let's say the maximum age, you can do that with this. Let's say if you want to print average as well. So this would give you the average as well. Now just note down these keywords. If you have any doubts, you can ask me. Just unmute your mics and you can interact with me. Okay, so let's say if you want to print all the unique, names. So let's say if I print all the unique names, so because all the names were unique, so that's why it has printed all the names. Let me insert one more. Okay, so now if you see, there are 2 entries for Kanta, and if I just want to print the unique names, so you can do that with this. So now distinct is a keyword that is used to do that. Now suppose if you want to count how many entries are there in your if you want to count, say, how many rows are there in the table, so you can do that with this. So because it is simply counting the name columns, how many entries are there in this name column, so it is telling you how many rows are there. If you want to see how many distinct names are there, you can do it with this. Okay. Now if you see this last query, sometimes you may want to print the column name. So right now it is printing it exactly as count distinct name, which was specified in the query. So let's say if I want to give this as a specific name, so the keyword to do that is as. So if you want to print, say, this as distinct names, so now it will show you distinct names while printing the query. So the keyword to do that is as. Any queries so far? Guys, are you facing any hurdles in understanding the syntax? Let me know.
No, sir.
Okay. So, such simple queries you can always, try executing. I'll send a sample database to you guys, and you can start running these basic queries on that sample database. So before that, let's say, so mostly you will find the sample databases with the extension .sql. So .sql would be the extension for all those files. The dumps that would be available on the internet, they would be with the extension .sql. So if you want to import a particular .sql file into your MySQL terminal. So this you can do with this command. So source, and then you would specify the path of that SQL file where you have kept it. So I can show you that in my downloads folder. Just give me 1 second now. Yeah, in my downloads folder, there is this MySQL sample database. Just copying the name. Okay, so if I want to import this database, so I will do this. So you can see that it has started importing the database. Okay, so whichever tables were there inside this database are now imported. Now let's say if I want to see what was the database that got imported, so I can just type the command show databases. So this is the database that it just imported, classic models. So this classic models database, if I want to shift to this database currently, so if you want to see which database I'm currently using, so the command to do that is select database. So right now, since I just imported this, so the database that I'm using right now is classic models. Okay. So if you want to switch to this another database, so that you can do with use command. Okay. And the switch is also there. You can use \u to switch to another database. Okay. So if I want to see what all tables are there in this database, so the command to do that is show tables. So if you see, there are so many tables in this database. So let me give you a whole overview of what this database is all about. So look at this schema. Is the schema clearly visible to everyone?
Yes, sir.
Yes.
Okay. So you could see that there are 8 tables. So I mean, this is the schema for this the same database where I have 8 tables. And for every table, I have certain attributes. So let's say for the product lines table, I have a product line attribute, a text description attribute. Attribute is synonymous to columns as well as field. Okay. Then HTML description is another attribute, and then image is another attribute. Okay. Similarly, there is an employees table, an officers table, and so there are 8 tables that we have with us. So if you remember, if I want to see how to check what attributes are there in my particular table, so that is done with the help of describe keyword. So customers is the name of the table that I am interested in. So these are the attributes that I have. So you see that this customer number is an integer type. Now, okay, I'll discuss the concept of keys in this class. So you see that this is PRI, the key corresponding to the key entry. You have a PRI there. So in essence, there could be 3 types of keys. One is a primary key. I mean, corresponding to this key attribute I'm talking about. So there could be a primary key. So primary key indicates that all the entries for this particular column, they will not be null and they will all be unique. So just remember that. No entry in this column will be null, and all the entries would be unique. So that's the concept associated with primary keys. Okay. Similarly, if you have a UNI here, there could be a UNI here. So which tells you that there is an index associated with that particular column, and each entry in this column, it may be repeated. So do not confuse it UNI with unique. So each entry in this column, it may be repeated, but there has been an index which is created on it. So that's the concept of unique. Sorry, I just mistakenly I explained so for unique, it is similar to this primary, but it can have null values, but all the values would be unique. In MUL, or you can say it to be multiple, so there might be multiple values, which are repeated for a particular field, but this particular field, sales rep employee number, is referring to the primary key of some other table. So let me get back to the schema. So before that, okay. So look at this particular table, customers. So in this customers table, you see that there is a star associated with the customer number. So you can assume this customer number to be a unique identifier for this customer. So this customer number can be a primary key because it uniquely identifies each customer. And if it is uniquely identifying each customer, then corresponding to that customer, I can also have all the entries: credit limit, sales rep employee number, country. So if you just tell me what the customer number is, I can get all these entries corresponding to that customer number. Okay. So this customer number is unique for each customer. So that means customer number is the primary key. Can you please confirm that whether primary key concept is clear to you or not?
Yes, sir.
Okay. Now next comes the concept of unique. So in unique, you can have null values, but all the elements would be unique in that particular column. So if you see a unique corresponding to UNI corresponding to the key field, so there you can have null values, but all values would be unique. So you cannot have more than 2 null values. Just remember that. And finally, there is MUL, where you can have multiple repeated entries. Now, if you see that this customer number in the table payments is referring to, so this row, or you can say this arrow, special arrow, it tells me that the customer number is referring to the customer number of the customers table. So inside this payments table, I have a field known as customer number. This customer number field is referring to the customers table field customer number. So this means that this customer number is the foreign key for this table payments, and it is referring to the primary key customer number of the table customers. So what is the use of this foreign key is that, so you remember that you will always have unique values in this primary key customer number, right? So now, because this customer number is a foreign key for this table payments, so it cannot have any new values which are not there in this customers table. So let's say you are making a database for let's say Amazon.com, and Amazon.com stores all the customer numbers in one table customers. But corresponding to all these customers, it also has another table payments. So you would want to ensure that there should be no no new customer which exists in this payments table. I mean, all the customers that are there in this payments table, they should always be there in the customers table. So that's why this foreign key constraint is there, which helps you to assure that all the customer numbers that are there in the customers table will be there. This table will not have any new customer numbers which are not there in this customers table. Okay. The second thing is that, let's say if you want to alter a customer number which is not there in this customers table, so if you do that, then it will show you an error, because the foreign key constraint, it will forbid you to do that. Okay. And the third thing is that in your primary key constraint, you were not allowed null values, right? But however, in your foreign key, you can have null values. Here you can have null values. But in this particular table customers, you cannot have null values for this customer number table. These things will get more clear when you will, has Prafulla ma'am covered the ER diagrams in the lecture? Can someone confirm that?
Yes, sir.
So you would know of this primary key constraints and foreign key constraints, right?
Yes.
Okay, so you could have told me that. I mean, I need not explain these concepts again then. Okay, okay, let's get to writing some more queries. Just give me a second. Okay, so we create a team and okay, so okay, so let's say we want to have some more constraints, or you can say some more keywords in the where clause. So this is how you can do that. So suppose, just give me a second. So suppose you want to print the name where say the age of where the age is between say 23 and 25. So you can do it in this way. So if you want to have all the employees between the ages of 23 and 25, you can do it with the between keyword. Okay. Okay. You can also use relational operators on if you want. So relational operators, they also work. Okay. Okay, so let's say you want to have all those employees, let's say where age is less than say 20. So just give me a second, let me make it a valid query. So let's say age is 25 and okay, so age is greater than 30 and say or rather I would say, or then this query would run. Then I mean it will print all those employees with the ages greater than 25 and ages less than 20. So basically it is ignoring all of those employees or all of those names with the ages in between 20 to 25. Okay. You can have, or we have used and. You can also do it with say something like okay, let me move to one more important keyword. So say you want to sort all the names by the age column. So you can do that by the keyword order by. So if I go by order by age, so just let me print it again. So these are the names. I'll also print the age so that you can see that these ages are also sorted. So if you want to sort all the attributes by age, so this is how you can do that. Refer to the order by keyword. Okay. Yeah. So let me do some more. Okay. Just for those who have joined in between, if you prefer, I mean, a website-based teaching mode, then I would recommend you to go through this W3 Schools website. So here you would find very easy SQL instructions where you can understand the syntax and the different keywords. Okay. So these are the different keywords that we will be discussing in the subsequent labs as well. Okay. So for now we have discuss the select clause, select distinct, where clause, and or you can have not as well. Okay. You can have null. Oh, let me come back. Let me go to null then. Let me have say just one more row where I insert the name as null and say the age as 20. Okay, so if I show you so there is a name with the thing is null. So let's say if I want to print all those rows where the name is null. So you can do that with this. Null is, remember that null is a special keyword. You cannot use the equate command to, compare it with null. So you would be doing this with, so let's say select age. You can say select name as well. Where say name, so is the keyword. So it will show you. So if you want to compare with null, so is the keyword to do the comparison. Similarly, if you want to have, all those names printed where you do not have a null entry, so this is how you can do that. Okay, so is null and is not null. Okay. Now, sometimes, let's say if I show you this database, just give me 1 second. So if I use this classic models, okay, so if I show you all the entries in the table customers, so you see there are 122 rows and you are unable to see all the rows. So let's say if I ask you to print only the top 5 or top 10 rows, so that you can do with this. So let's say if you want to only print 5 rows, so limit is the keyword with which you will specify how many rows you want to print. So insert. What the hell? Just. So it will show you only the top 5 rows. Okay. So with limit keyword, you can specify the number of rows that you want to print. Okay. Let me see if I'm missing anything. Okay, that was covered. Okay. Let's say you would want to have a regular expression based comparison. So if you want to have a regular expression based comparison, you can do it something like this. Okay, so select, let me switch to that database because it is much easier to handle. Use DB. So let's say if I want to do this, say select, say names from this table T name, where say name with the name attribute we want to compare with say all those names which say end in anta. Okay, so if I with the say let's say if I want to end all these names with the names ANTA, so this is how I can do it. Okay, so % tells me there can be any number of characters So percent is a regular expression. This like keyword tells me that I am using a regular expression for comparison. Inside this, you see that there is a percent operator. So percent tells me there can be any number of characters before this ANTA. Okay. So all those. So this means that all those names that end in ANTA. So it has printed all those names. So let's say if you want to have all those names, let's say which start with S. So that you can do with. Okay, so it's starting with S, but let's say if I print it, so it's showing me an empty set because it is starting with an S and it is not telling me that all the, characters after it. So if I want to say that percent is, oh wait, just let me check. Am I missing something? Okay, percent is 0, 1 or more, and underscore is a special character. Oh, sorry, single character. Okay. Let me see with the wildcards. Just give me a second. Okay. I was misinterpreting. So cap means that which is not. Okay. So what is this character for? Okay. Yeah. So let's say if I want to print all names which start with S, then I can do it by simply using this. So S is the string with which I want to start, and the percent tells me that yeah, it should. It can have anything afterwards. So yeah, so this is how you can do it. Okay, so a simple query to you guys. So can you print, say all names?
Sir, I have a doubt.
Tell me.
So in the previous one where you did the cap sign before this, why didn't it print the other ones like Fanta, Manta, and all of those? Because this is not S and anything, right?
No. So I just said which is not S. This cap tells me which is not there.
So then why didn't it print the other four? Like, doesn't that satisfy it?
Okay, it just give me a second. So it tells me that cap tells me which is not inside. I think this cap works only inside the square brackets. Let me just check. Just check it once. So if I do this. Okay, so if I do this, this is not S and then percent. So it tells me which is okay. Yeah, I get this point now. So what it is trying to do is that which is not here and it can be anything afterwards. So this is this represents any character not in the brackets. Let me see, but it is saying that it runs on SQL Server. Okay, just 1 second, I'll just confirm it. I'll get back to you on this. Maybe this, even though this keyword is running, I am not able to interpret what this is doing. As per the manual, it says that it is representing all those characters which are not there inside the brackets. but then it should print each and everything. But this is not doing that. So I'll get back to you on this.
Okay, sir.
Yeah. Yeah. Note down a couple of queries. So I'll show you the table. Okay. Okay, can you count all those people whose age is, say, between 23 and 25? Say from 20 to 25? Can you write down a query for that? So I'll show you a simple usage of count. So if you just want to count how many, say, names are there, let's say all those distinct names, or let's say all those names. Say where this so it is only telling me that there are 5 names. So all these 5 names, because they end with anta. So that's how you can use count. So let's say if I want to count all those names, or if I want to count the number of people who are between the ages 20 and 25, how will you write that query? You can write it in the chat box. This is just for your reference. You can type your answers in the chat box so that I know that you are in sync with this class.
So can you repeat?
So you want to count all those people who are in between the ages of 20 and 25. Yes, Vishwesh has given the correct answer. Just a note that Vishwesh, it will end with a semicolon.
Yes, sir.
Yeah, everything else is correct. Okay, these simple queries you can try on this data set that I will share. I will also share the lab assignment that you need to do, but this you can submit after the next lab. So after the next lab, you will be given 3-4 days. So you can submit it, say, so today is Tuesday. So next Tuesday, it would be 22. So you can submit the assignment on 25. Okay, I'll share the lab document as well as age is greater than 20 and age is less than 25. Yeah, this will also work. Yes, Sai, this will also work. Okay, so I will share the assignment as well as the database for that. I will also share the sample queries that you need to know. Okay, just before that, I showed you like how to create sample tables. So I will share a subset of commands that will be that you can follow from the document itself. So I'll show you the lab assignment itself today. Just give me a second now. Okay. Yeah. I will also add the instructions to the assignment. Okay. So you will have a university database, and I will show you the exact files. So these are the queries that you have to answer for that particular course, for that particular database. So if you haven't installed MySQL, please do it as soon as possible. So these are the queries for your assignment, and I will provide you the these are the set of instructions that you can just copy paste into your MySQL to enter the values for creating the database. And these are the tables that exist in the database. Okay, I'll explain one sample query. So here you have the table classroom. You have certain fields or columns: building, room number, capacity. Now, if you see that this primary key, so this is telling me that combined building and room number, all the entries, when you look at the two columns together, so they should be unique. So this is how you enter the primary key constraint. Okay. So numeric 4,0, it tells me that it will be a numerical entry. It is another variant of integer type. Again, this new table department, it has a table, primary key department name. Yeah, so if you see that there is a check, so this check is a constraint where you always see that the budget value should be greater than 0. It cannot be negative. So you can add such constraints while creating your tables. So if you are inserting any values where the budget is less than 0, so it will not work. It will throw an error. Okay, so just focus on these queries. Okay, so how do you define foreign keys? So with foreign keys, you use the foreign key and which foreign key, which key is the foreign key and where it is referencing. So it references the department table, and you have set the on delete set null. So if you delete something here, it would be, here the corresponding entry in this particular table would be null. So let's say if there was an entry, say 1, 2, 3 in the department table, which also has a department name. So you can see that this also has a department name. So because this department name is the primary key, let's say there was an entry which was 1, 2, 3. So if you delete this entry 1, 2, 3, so in this particular table, because foreign key values can have null, so but it cannot have an entry 1, 2, 3 if it is deleted from the original table department. So if you delete the 1, 2, 3 entry from this department name in the table department, so in this particular table, this 1, 2, 3 on deletion would be set to null. So that's why you have written that on delete set null. Okay. So these are for the tables. These are just constraints that have been put so as to ensure that the values are correct. It makes sense.